other things. The actual main, quote unquote, main function call inside of the, and remember, we're writing this as C, receives a pointer called MFT. That points to the actual data block. So this will get called, and the data block will be all fixed up with all the function pointers. So the nice thing about this, even though you can see I'm doing some inline assembly, you'll also notice that I have local variables. I can actually call functions and write the code similar to the way I'd write C. I can actually add additional functions, and when this compiles, it actually poops out just a giant hex blob that I can cut and paste into my injection code. There it is. So that's called my quote-unquote shellcode compiler, and we gave that out in our Advanced Rootkit class earlier this week. Okay, so we allocate the memory, we inject that blob that you saw, we branch to it. As soon as the blob is done, we cloak it by moving it into the holding pen, and when our hook fires on render world, we're going to do the same thing all over again, uncloak, move it back, branch to it. When it's done, it recloaks, and the process just repeats forever. This is the code running. Those A's are not real. There's code right there, and it's executing right now. So there you can see the memory cloaking with the shadow branching working flawlessly. So, the only thing we do now is once we've got this working is we force in-game events. So we know where the locations of all the various functions are inside of World of Warcraft for casting spells, moving to a location, picking up all items from an inventory, etc. There's probably about, I think, 9 functions that are used in this manner. All we do is the injected code will force a call against one of those functions to get something to happen, say casting a spell. And then when it returns, it'll return back to the main thread. You can also do things in the chat window and other things like that with the same system. Okay, this is the complex slide, I understand, but this is the entire thing. So here comes the main thread, render world, hardware breakpoint, uncloak, jump to the injected code page. The injected code page reads from the message what it needs to do, and it proxies the function call, the cast spell by ID, script execute, clear target, etc. Then returns, recloaking, and restores back to render world. Warden didn't see us. This is the remote window that drives it. We call it antifreeze, and it has the scripting language under the hood. It uses Lua. It uses supervisor on the remote system, and in theory, if I don't release it, I don't expect it to be banned by Warden. Now, how would we make a better Warden client? Let's look at the other side of it. First of all, going to ring 0, but as we talked about earlier, that might not be within the policy for Blizzard. However, we know Punkbuster goes to ring 0, and they detect a lot of cheaters. Really, really good tricks for detecting ring 0 code, even without having ring 0 code. Do things with timing to see if you're being debugged. Scan the stack. You just saw I called cast spell by ID. If somewhere down inside cast spell by ID, it scans back on the stack and sees that it wasn't called from the location that it thinks it was, that is the return address isn't set to the one it thinks it should be, you could use that as an anomaly detection. Furthermore, while we're calling those functions, remember we're in an uncloaked state. So if you could somehow randomly branch to the warden from a non-predictable location, that might cause a lot of problems. Of course, we can solve all those problems, but it just makes a lot more work for us. Another thing to do, and this would work really well, if the warden does different games with exceptions, chances are my rootkit is going to fault up what the expected exception chain is, and they're going to be able to detect it. And finally, and this one's just so brain dead simple, just use the DR registers for something important that they have to be there. Now I can't use them for my shadow branching, because I would mess up whatever's already there. So this is kind of my concept for the better warden. It's called Fear of the Unknown. This is basically what they have. Update at any time, require a positive response, scanning for stuff you know should be there, and then scan for stuff you know shouldn't be there, and put the entire go, no-go decision on the server. Disseminate multiple versions of this per account. So the version of Warden that I have isn't the same one that you have, so even if I reverse engineer mine, it's not going to help you. The theory being REs can't get their hands on all the versions. There are some other applications of this technology. I think that rootkit technology, such as like the supervisor, can actually be used to watch a system that you think has been compromised. Now here's an application to security that has nothing to do with Warcraft. If you can covertly monitor a system and the malware and tools that are on there can't tell that you're doing that, whether you're doing that through a rootkit-like technology or a hypervisor layer, this is actually an application that would allow you to catch bad guys. One idea that I have here is something called active forensics. Instead of looking at just a hard drive, you could actually collect runtime data from a system as it's being used, perhaps by an attacker. An example, let's say they have an encrypted command and control channel, and you want to get the decrypted packets. Obviously they're going to get decrypted, but they're going to be decrypted in memory and passed to some function. Put a breakpoint there and sniff them out of memory. You have the decrypted packet stream. It's just one example. Just some notes on that. Corporate espionage now outranks malware as the #1 security concern in the enterprise, according to an analyst firm. And according to the FBI, $250 billion a year being lost in espionage. And our good friend John Pescatore says, yes, there is a role for stealth in the enterprise world. So my hope is that maybe some of this rootkit technology can be used for good to catch bad guys. This is an upcoming book Gary McGraw and I are writing. We're going to try to get away with putting as much as we can in here without being sued by Blizzard, but we'll see. And it'll, of course, include much more detailed information on all things I just showed you. I got done about 10 minutes. I got done quite a bit early. Are there any questions? Yes, sir.
You said that when the word runs, it grabs input text from other windows on currently running the system when it runs?
Yes.
Is it possible they try to have a Word document open with personal or classified information as far as the company's concerned? If the word's actually holding that up to Blizzard?
The question was, if you have an application open with potentially sensitive information, will the warden read it and will the warden send that back to Blizzard? The answer to the question is, first, yes, it will read it, but no, it won't mail it back to Blizzard. The way the warden works is it actually hashes the strings and compares them against a set of what are called banning hashes. So no personal data actually gets sent back to Blizzard as far as I know. Yes, sir. The question was, will hardware virtualization change this whole thing? I could imagine writing a bot for the hypervisor. That would be really cool. That would be really, really neat. And it would be really difficult for a warden to detect that. Okay, thank you very much.